Hi everybody, welcome back. Miss Calabrese here. So in this video, we're going to be continuing our introduction to basic anatomy and physiology. So we're going to be covering some of the general body regions and a little bit of terminology that you're going to need to know as we move forward. All right, so starting off, we will discuss standard anatomical position. So standard anatomical position is how we refer to the body whenever we're using these kind of regional terms to describe different places on the body or direction on the body. We're always going to be referring to the body in this standard anatomical position, which is a person standing up with their feet facing forward, their eyes level facing forward, their palms facing forward. So this is our standard reference position. Okay. And now we'll get into some of the kind of interior cavities in the body. So the major organs that you have in your body are going to develop within one of two major cavity systems. So we have your dorsal cavities. The dorsal cavities are those on the posterior, the back side of the body. And then you also have ventral cavities. Those would be the cavities on the anterior or belly side of the body. And then each one of those sets of cavities has some subdivisions that we'll get into here. Right, so looking at the dorsal cavities first, so the dorsal cavities we can subdivide into being either the cranial cavities or the vertebral. So cranial cavity is where you keep your brain. So cranial cavity is in the head. The vertebral cavity, sometimes called the vertebral canal, is what houses your spinal cord. Right, so these are the cavities represented in yellow here on this image, which are housing the brain and spinal cord. So those are your dorsal cavities. Both of these dorsal cavities are going to be surrounded by layers of protective tissue called meninges. So covering the dorsal cavities, you've got three meninges that are protecting the brain and spinal cord. Now moving forward to the belly side of the body in your ventral region, we've got a couple cavities here as well. The thoracic cavity is the one, the most superior one, so the one towards the top of the body. So this is the thoracic cavity you find in the chest region. So it's basically surrounded by bones, right? So it's surrounded by your ribs, your sternum, and your vertebrae. And then within that thoracic cavity, we're going to have some smaller subdivisions. So looking at the thoracic cavity from this point of view, again, it's represented in blue here. So inside of the thoracic cavity, we've got some smaller cavities, and those are the right and left pleural cavities. So the pleural cavities each one of them holds one of your lungs. And then you've also got a pericardial cavity. The pericardium holds the heart. Right. And then we've also got this area that's kind of in between the pleural cavities. It's represented as like a dashed line here that's sort of in the middle of the chest between the pleural cavities. That's your mediastinum. And so the mediastinum is just this region between the pleural cavities where we find the pericardium and also some of the major vessels that are coming off of the heart, along with the esophagus and some other structures in there. Okay, so again, the pericardial cavity is a cavity that's within the thoracic cavity, and that lies in the middle of the chest. This is another view. So we're looking at a cross-section of the body. So we can see, allow me to highlight here for you. So the anterior side of the body, so this is the belly side, posterior, this is the back down here. And we're kind of cut through the chest so that we can see there's a lung here, there's a lung here, and then we've got the heart sort of in between the lungs, but more towards the anterior side of the body. And so the heart there is lying within the pericardial cavity, which is within the mediastinum. Okay, so again, the entire thoracic cavity sits in the chest above a major muscle called the diaphragm. So the diaphragm is a muscle that's kind of like this dome-shaped muscle right here that basically separates the thoracic cavity from the abdominopelvic cavity. So everything above the diaphragm there is going to be thoracic cavity, and everything below is going to be abdominopelvic cavity. All right, so moving into our lower ventral cavity, which is the abdominopelvic. So this extends from the diaphragm all the way down to the groin, and it's completely surrounded by muscle. Not as many bones are surrounding down here as there were up in the thoracic cavity, right? So we don't have rib cage surrounding the abdominopelvic cavity. We can kind of subdivide the abdominopelvic into two different regions, the abdominal region and pelvic region. These two regions don't have there's not a clear kind of anatomical demarcation between the two. There's not a membrane or anything separating them, but we kind of refer to them separately because they contain different organs. All right, so no matter which one of these body cavities we're talking about, all of these cavities are regions in the body that are surrounded by membranes, in particular serous membranes. So serous membranes are double-walled, fluid-filled membranes that are going to be surrounding either one organ or several organs, right? So in every serous membrane has two layers, a visceral layer, which is the innermost layer, and a parietal layer, which is the outermost layer. And then between the visceral and parietal layer of every serous membrane, there's going to be fluid or serous fluid between those two membranes. So here's a way to kind of visualize what a serous membrane works. So your pericardium that surrounds your heart is a serous membrane. It's a double-walled, fluid-filled membrane. So you can think of it like this, where we can see the visceral layer. So visceral pericardium in this case is the layer that's actually touching the organ. And then the parietal layer is the outermost layer. And then in between the visceral and parietal layers where we have the serous fluid or pericardial fluid in this sense, right? And so we could be referring to the pericardium here. We could be referring to the pleura that hold the lungs. So any one of these membranes is going to be considered a serous membrane because we've got a visceral layer and a parietal layer. Oops, there we go. A parietal layer, and then in between those two, we've got fluid. And the purpose of a membrane like this is protection, right? So you can imagine if you're surrounding each one of your squishy organs with a nice cushy water balloon, that's going to help keep it nicely protected. Okay, so again, we mentioned pericardial cavity. The top one here, pleural membrane. So those pleura are the serous membranes that surround your lungs. So you have a right and left pleura that's covering each one of your lungs. And then you also have a peritoneum. So peritoneum, this is the largest of your serous membranes. And this is the one that's found in your abdominopelvic cavity that's covering many of those abdominal organs. All right. So moving on to some more terminology here. So we're going to have to get used to starting to use the actual anatomical terms, scientific terms for the different regions of the body. And that's to make sure that we're all on the same page and talking about the same structures, and also to get you kind of familiarized with this terminology because there is going to be a lot of new vocabulary here for you. So the idea is no matter what terms we're using, we're basically always going to be referring to the body in the standard anatomical position, and then we can use relational terms to describe where things are on the body once we know that we're all standing in this position. Okay. So as far as some regional names that you're going to have to know, you'll be able to find these in your learning maps, and you can pause and zoom in on this PowerPoint if you want to look at these different labels. So just a few of the major ones that I'll kind of go over here. So cranial refers to the skull, the region of the skull. Cervical refers to the neck. Cubital refers to the elbow. Carpal refers to the wrist. Patellar refers to the front of your knee. Orbital refers to the eye. Thoracic refers to your chest. And inguinal refers to your groin. And as you can see, there's still a lot of other terms that are labeled on that figure there. Some more here. So metacarpal refers to the hand or the palm of the hand. Plantar refers to the sole of the foot. Buccal refers to the cheek. Axillary is the underarm, femoral is the thigh, gluteal is the buttocks, tarsal is the ankle, digital or phalangeal could be referring to either toes or fingers. And so here's some from the back. So acromial is the shoulder, scapular refers to the shoulder blade itself, vertebral refers to the spinal column, um, cubital is the back of the elbow, sacral is kind of low on the back between the hips. So again, just I'm not going to go through every single one of them, but a lot of different terminology, and you should start to be kind of making flashcards of these different words and make sure that you're familiar with all of this. All right, so quick concept check here. What are the dorsal cavities of the body? What are the ventral cavities? And then what separates those two main ventral cavities? All right, so the dorsal cavities are the cranial and vertebral. The ventral cavities are the thoracic and abdominopelvic. And then the structure that separates those two is the diaphragm. Okay, and then just to kind of review some of this terminology, what region of the body does each of these refer to? So if I say lumbar, cervical, brachial, occipital, carpal, sacral, or inguinal, would you know what region of the body I'm talking about? So lumbar would be referring to lower back, cervical is neck, brachial is the arm, occipital is the back of the head or back of the skull, carpal is wrist, sacral is between the hips, and then inguinal is groin. Right. So just to familiarize you with some other body positions, so we're usually referring to the body in standard anatomical position, but if we're going to be referring to other positions, they have names too. So prone is describing someone who's laying face down. Supine is someone who's lying face up on their back. And then getting into the regional, or I'm sorry, the directional terms. So the directional terms describe differences, different places on the body here. So superior is referring to things that are above something, so closer to the top of the head, to the top of the body, whereas inferior refers to below. So these are kind of like relative terms. So superior is more towards the top, inferior is more towards the bottom. Right. Anterior and posterior. So anterior refers to towards the front, posterior is towards the back. These terms are going to be interchangeable with ventral and dorsal. So ventral is towards the front or the belly side. Dorsal is towards the back or the back side. And the reason that these are interchangeable here is because humans have this weird habit of walking on two legs, whereas most other critters are walking on four. So their anterior side and ventral side are not the same, but they are for us since we stand up on 2 feet. Medial and lateral. So medial is referring to closer to the midline. So right here we can see maybe the sternum is medial to the lung. Lateral is closer to the side or to the outside. So these lungs are lateral to the sternum, which is the bone right in the middle here. So medial is toward the midline. Lateral is further away from the midline of the body. All right, and then proximal and distal. So proximal and distal, we typically reserve only for when we're talking about the limbs. So we're talking about arms and legs. We'll use the terms proximal and distal. Proximal means closer to, distal means further away from. If we're talking about the arm, for example, here, the shoulder is proximal to the elbow, but the elbow is distal to the shoulder, but the elbow is also proximal to the wrist. All right, so proximal meaning closer to where we started. Distal, when where we start is where that limb is attached to the body, which is way up here, and distal meaning further away from that point of origin. All right, a few more directional terms here. So ipsilateral and contralateral. So ipsilateral just refers to if we're looking at something on the same side of the body. So if we're looking at this lady's right arm and right leg, then we're looking at the ipsilateral limbs. If we're looking at the right arm and left leg, then those are contralateral because they're on opposite sides of the body. Contra means against. Right, superficial and deep. So deep just refers to kind of deeper within the body. Superficial is closer to the surface. So deep is closer to the core, superficial closer to the surface. And then visceral and parietal. So we mentioned these already in reference to your serous membranes, but visceral is always going to be pertaining to the covering of an organ itself, so closer to actually touching the organ. Parietal is further out, so closer to the cavity wall. So in this picture here, the arrows are pointing to the visceral pleura, which is actually touching the lung, and the parietal pleura, which is the outermost layer of that membrane. All right. And now let's describe body planes really quickly because this is going to be important to understanding when you see different pictures in your textbooks or online, wherever you're looking. You should be familiar with this terminology so you understand where you're looking in the body. So we can kind of divide the body into planes, and we describe those planes by the cuts or the incisions that we would make to create them. So a sagittal plane is one that's going to separate the left side of the body from the right side of the body. So sagittal separates left and right, divides the body in half. Um, a sagittal plane could either be mid-sagittal, which means directly through the midline. So I'll highlight that for you. This is a mid-sagittal plane that's going directly through the midline of her body here. Um, or we could have a parasagittal plane, and a parasagittal plane is one that's going to be off to the side. Still separates left from right, but not necessarily in equal halves like a mid-sagittal line would. All right, so sagittal just separates left from right. A transverse or horizontal line is one that's going to separate the body top from bottom. So a transverse or horizontal section could be anywhere. I could have a transverse section up here in the head. I could have a transverse section of the leg, but it's just separating top from bottom, cutting in a horizontal direction. And then frontal or coronal, a section that's frontal separates the front from the back. So kind of hard to illustrate in a drawing like this, but it would be separating the front half of the body from the back half of the body. All right, so looking at those sagittal planes again. So again, a mid-sagittal plane is one that's directly through the midline of the body, separating the body into equal left and right halves. A parasagittal plane is any plane that's separating the body left from right, but not necessarily in equal halves. All right, and then a frontal or coronal plane, again, separating the front from back. Again, not necessarily in half, but just separating front from back. And then a transverse plane separating top from bottom. Right? Another way to visualize it, looking at instead of looking at the whole body, looking at just a brain here. So we see the first picture here is of a mid-sagittal section of the brain. So we're cutting directly through the midline of the brain, separating left from right. The coronal section here is separating the front of the brain from the back of the brain. And then a transverse or horizontal section is separating top from bottom. All right. So a little bit more terminology, and this is just for useful for referring to different regions of the body, especially when a patient comes in complaining of pain. It's good to know these terms so you know where to pinpoint and how to describe where that pain is. So we can do this in a kind of simple way by dividing the abdominal pelvic region into 4 different quadrants. Or we can be a little bit more specific, and instead of 4, we can divide it into 9 regions. Right, so if we're keeping it simple and focusing on just the quadrants, so if we look at the abdominal pelvic area of the body, we can divide it into right upper quadrant, right lower quadrant, left upper quadrant, and left lower quadrant. You can just use abbreviations for those, so RUQ, LUQ, to separate these different regions of the body, right? And where those 2 lines intersect is right at the umbilicus or right at the belly button. If we're being a little bit more specific and we want to look at 9 different abdominal pelvic regions, then we're going to use more of like a tic-tac-toe style grid, where we're going to separate this abdominal pelvic into 9 different regions. So we're going to have 3 regions on the right side of the body, and then 3 regions on the left side of the body. So we'll start by describing the right side of the body here, and then there will be 3 in the middle. So this top corner up here, top right corner, is your right hypochondriac region. On the right side, so hence right, hypo meaning below, chondriac referring to the cartilage of the ribs. So the right side just below the ribs is the right hypochondriac region. Just below that sits the right lumbar region. So right lumbar region is just kind of in the lower back sort of region on the right hand side. And then the right inguinal region is the lowest part on the right side of the torso, close to the groin. Right, and then we're going to have those same things on the left side. So we'll have mirror image on the left. So you have a left hypochondriac region, a left lumbar region, and a left inguinal region. And then in the middle, we've got another three regions here. Those are going to be the epigastric, so epigastric meaning above the stomach, umbilical meaning right at the belly button, and then hypogastric meaning below the stomach. Right, so those are your 9 different abdominal pelvic regions. All right. Um, Now, a lot of what we're going to be talking about in this course, especially in terms of physiology, is how the body maintains homeostasis, how it maintains equilibrium. So homeostasis is just a set of stable internal conditions that your body is continuously trying to maintain. So this is everything from maintaining a stable temperature to maintaining a stable blood pressure, blood sugar, blood pH, all of these kind of stable internal conditions that help to keep you alive. All right, so failure to maintain homeostasis is what leads to illness and then eventually death. Right, so if we can maintain homeostasis, then we can stay, healthy and alive. All right, so lots of things are going to be threatening homeostasis all the time, right? So our bodies don't exist in little bubbles, right? We're in the real world. We have to interact with different things in our world. So lots of things can threaten to throw off our homeostasis. So for example, if it's a really hot day out, then that's going to threaten to raise our body temperature above our homeostatic set point. And so the body has to figure out how to deal with that. If it's a very cold day, then we have to figure out how to deal with that. If it's been a while since we've had a meal, then we have to find a way to keep our blood sugar stable, even without continuous food supply. If we've had too much to eat, then we have to figure out how to get that glucose into our cells instead of running rampant in the bloodstream. Okay, so there are lots of things that are going to be threatening to homeostasis, and your body has ways of dealing with those to get us back to homeostasis. All right, and the main way that we get back to homeostasis is through a feedback loop, or negative feedback loop to be specific. So 3 basic components of a feedback system are the receptor. The receptor is what's going to be receiving the information. So for example, say it's a hot day out, I'm going to have receptors on the surface of my skin that are going to be able to tell my body that, hey, it's hot, my skin feels hot. Um, so that receptor is then going to send a nervous signal to the control center of my body, which is the brain. That receptor will tell the brain, hey, it's hot outside, maybe we should do something about this. And the brain, or the control center, is then going to send out an effector signal to get us to do something. So in the case of a really hot day, maybe that effector signal is to produce more sweat, to try to cool the body through evaporative cooling. Right, so there's always going to be these 3 components to any feedback loop, and that is an afferent pathway, which is going towards the control center, and then an efferent pathway, which is coming from the control center, a way to control the body to maintain homeostasis. Right, so receptors, for example, these could be surface receptors on your skin that are telling you things like skin temperature. They're telling you that there's presence of something painful or whatever it might be in your environment. So that receptor is what's receiving the information. Again, the control center is the brain, usually the brain, but sometimes the spinal cord. That's where that information is going to be processed. And then that control center will send a message out to respond to whatever new stimulus had been received. Right? And then the effector is the efferent pathway, or the pathway leaving the brain toward whatever the effector cell is, so that we can regain control of our homeostasis through whatever process it might be necessary at that point. All right. So this kind of thing that I've described, where we're kind of trying to maintain a stable set point, that's an example of a negative feedback loop. So negative feedback is when we're trying to reverse a change from our controlled set point. So negative feedback is basically how most thermostats work in your house, right? So if temperature is rising in your house, the thermostat has a receptor, right, a thermometer that's going to be able to pick up that change in temperature and say, okay, temperature is getting a little bit warm. That receptor is going to send the message to the thermostat. It's going to say, okay, the control center now, we have to turn on the air conditioning because the temperature is getting too hot. And then as the air conditioner, the effector, begins to lower the temperature, eventually we get back down to the set point, whatever that homeostatic set point is, and that's going to trigger the control center to turn the air conditioner off again, right? So negative feedback is keeping us at a homeostasis level. Positive feedback is kind of the opposite. So a positive feedback loop, instead of maintaining a stable set point, actually pushes us out of our stable conditions. So this one will reinforce a change. So there really aren't too many examples of positive feedback loops in your body because generally we're trying to maintain, stable homeostatic conditions. But the one common example of this would be childbirth. So childbirth is a positive feedback loop where signals that are telling your body that it's time to give birth are just going to keep reinforcing themselves and keep pushing harder and harder until childbirth has happened. Okay, so a few questions here as a concept check. So what is homeostasis? What is negative feedback? And what is positive feedback? I'll give you a second to think about it. All right, so homeostasis is the maintenance of stable internal conditions, whatever those conditions might be. There's a lot of them. Negative feedback is a loop that's going to reverse a change in conditions. So if we change away from our set point, it's going to reverse that change and get us back to the set point. Positive feedback is going to reinforce that change in conditions, so continuously driving us away from whatever point we started from. All right, so hope this was helpful. Let me know if you have any questions.